Hello friends, in the last video we have seen the miscellaneous exercise from 1 to 11. Now in this video you will see the question number 12 to 20. Now let us start the miscellaneous exercise for the complex number. Now let us start with question number 12. Convert the following complex number in polar form and also in exponential form. Z is equals to 2 plus 6 root 3i upon 5 plus root 3i. Therefore, now multiply the given complex number, the conjugate of the denominator. Now what is the conjugate? 5 plus root 3i is 5 minus root 3i. Now simplify this, normal multiplication is there. Therefore, that is a 10 minus 2 root 3i plus 30 root 3i minus 6 root 3 into root 3 I square, 25 minus 3i square, and then you will get that is a 10 plus 20 root 3i minus 6 into 3 into minus 1, that is equal upon 25 minus 3 in bracket minus 1, and after simplification you will get 10 plus 28 root 3i plus 18 upon 25 plus 3, that is a 28 plus 28 root 3i upon 28. Now take 28 as a common, that is 28 common, then you can cancel from the numerator and denominator 28. Therefore Z is equals to 1 plus root 3i. This is of the form a plus ib, or Z is equals to x plus iy. Therefore, x is equals to 1 here and y is equals to root 3. Now this point lies in the first quadrant. Some of the students ask me in the comment box, that is how to find the angle. Now this point lies in the first quadrant, therefore the angle is very easy. It's in between 0 to pi by 2. We are finding the value of the r. Some students say that your speed is high, but you can slow down my speed with the help of your computer and mobile and mute the sound, and you can see each and every steps, and then by using your regular speed. Now tan theta is equals to y upon x, that is equals to root 3 upon 1. Therefore, theta is equals to tan inverse of root 3, and that is nothing but the pi by 3. Therefore, in polar form, that is a z is equals to r in bracket cos of theta plus I times sin theta. Now substitute the value of the r, that is a 2 cos of pi by 3 plus I times sine of pi by 3. Therefore, in exponential form, z is equals to r into e raised to I theta. That is a 2 into e raised to I pi by 3. Second, z is equals to minus 6 plus root 2i. It is of the form z is equals to x plus iy. That is minus 6 plus root 2i. The value of x is minus 6 and y is equals to root 3. Now this point lies in the second quadrant because x is negative and y is positive. Therefore, r is equals to in root of x square plus y square. That is a 36 plus 2. That is r is equals to root of 38. If you want to write this, then make the speed of this video slow. It is given in the facility is given on the laptop also, computer and mobile also. That is a tan theta is equals to minus 6 root 2 upon 2. That is a minus 3 root 3. This is the. Therefore, now we will change it. That is a. I made some mistake. That is a tan theta is equals to y upon x. That is a root 2 upon minus 6. That is a. And now keep this angle as it is. Therefore, theta is equals to tan inverse of minus root 2 upon 6, and that is equals to theta is equals to tan inverse of minus root 2 upon 6. Now in the polar form, z is equals to r cos theta plus I times sin theta. The value of r is a root of 38 in bracket cos of theta plus I times sin theta. And in exponential form, that is a z is equals to r into e raised to I theta. Therefore, root of 38 e raised to I theta, where theta is tan inverse of minus root 2 upon 6. This is in the exponential form. Now, next example, number 3, minus 3 by 2 plus 3 root 3 I upon 2. Now here again the complex number z is equals to minus 3 by 2 plus 3 root 3 upon 2 I. Now this is z is equals to x plus iy. Now here x is equals to minus 3 by 2 and y is equals to 3 root 3 upon 2. Now we will apply the formula for the modulus, that is a r is equals to in root of x square plus y square, and see this value 9 by 4 plus 27 by 4, that is a 36 by 4, and that is 9, and root of 9 is 3. Therefore, r is equals to 3. Now, x is equals to minus 3 by 2 and y is equals to 3 root 3 upon 2. We can find out the angle by using the tan theta is equals to y upon x. That is a 3 root 3 upon 2 minus 3 by 2, and the point lies in the first quadrant. That is a tan theta is equals to minus root 3. Therefore, tan theta is equals to minus tan of pi by 3. And therefore, by using the trigonometry, Now, to understand this concept, the given point lies in second quadrant. Therefore, tan theta is equals to tan of pi minus pi by 3. We have learned this in the trigonometry chapter in M1. Therefore, tan of theta is equals to tan of 2 pi by 3. Therefore, theta is equals to 2 pi by 3. In polar form, z is equals to r cos of theta plus I times sin theta. And the value of the z, r is 3. In bracket, cos of theta, cos of 2 pi by 3 plus I times sin of 2 pi by 3. Now, and in exponential form, z is equals to 3 r into e raised to I theta, that is a 3 dot e raised to I 2 pi by 3. That is a 3 dot e raised to 2 pi by 3 r. That is answer in the textbook, is not correct given. Next is, if x plus iy is equals to a plus ib upon a minus ib, then prove that x square plus y square is equals to 1. Now again, this is very simple. X plus iy is equals to a plus ib upon a minus ib. Now multiplied with by its conjugate of the denominator, and the term in the denominator is a minus ib, multiplied numerator and denominator by a plus ib. Therefore, a plus ib bracket square upon a square. I am making some mistake here. Now I will erase it. That is a square minus I square b square. That is a plus ib bracket square is a square plus 2abi plus I square b square. A square I square means what? It is a minus, and minus minus will become plus. Therefore, a square plus b square. That a square plus a square minus b square plus 2abi upon a square plus b square. Now separate this. A square minus b square upon a square plus b square plus 2ab upon a square plus b square into I. Now equating real and imaginary part, x is equals to, and imaginary part, x is equals to a square minus b square upon a square plus b square, and y is equals to 2ab upon a square plus b square. Therefore, x square plus y square is equals to, substitute the value, a square minus b square upon a square plus b square, bracket square, and 2ab upon a square plus b square, bracket square. That is a square minus b square bracket square plus 2ab bracket square upon a square plus b square, a square plus b square whole square now see this. Therefore, a square minus, now expand this, that is a square minus b square whole bracket square a raised to 4 minus 2 a square b square plus b raised to 4 plus 4a square b square upon a square plus b square bracket square. Now is a raised to 4 plus 2 a square b square plus b raised to 4, I had written there b raised to 2, but there is a b raised to 4. That is a, and these two terms get cancelled and you will get the value x square plus y square is equals to 1. Now the next question number 14. Show that z is equals to minus 1 minus plus in bracket root of minus 3 upon 2 bracket cube is a rational number. That is, it is of the form p upon q where q is not equals to 0. Now see this, we will expand this by using the formula a plus b bracket q. Now here, that is a minus 1 plus, that is a 3 into minus 1 bracket square cube, that is equals to 1 by minus 1 plus root 3i upon 2 bracket cube, that is equals to minus 1 plus root 3i bracket cube upon 8, that is 1 by 8 minus, now expand this, a plus b bracket cube, that is a minus 1 cube plus 3 minus 1 square root 3i plus 3 into minus 1 into root 3i bracket square plus root 3i bracket cube. Now next is minus 1 plus 3 root 3i minus 3 and root 3i square, I bracket square means what, 3i square plus 3 root 3 I cube, that is 1 upon 8 minus 8. Now we will simplify this, that is a minus 1 plus 3 root 3i minus 9 in bracket I square means what, minus 1, and again I cube means what, minus I, therefore it is written minus 3 root 3i. Now again that is 1 upon 8 minus 1 plus 3 root 3i, these two terms get cancelled, minus 1 plus 8, that is a 1 by 8 into 8, and that is equals to 1. Therefore, which is a rational number? Therefore, z is equals to minus 1 plus in root of minus 3 upon 2 bracket cube is a rational number. Now next is question number 15. Show that one minus 2i upon 3 minus 4i plus 1 plus 2i upon 3 plus 4i is a real number. Now very simple example, 1 minus 2i upon 3 minus 4i plus 1 plus 2i upon 3 plus 4i. Now make the cross multiplication here, that is 1 minus 2i in bracket 1 plus 3i plus 1 plus 2i into 3 minus 4i upon the product of the denominator terms. They are 3 minus 4i into 3 plus 4i. Now simple multiplication of the two brackets is given here. That is 9 minus 16i square. Now see this, 3 plus 4i minus 6i minus 8i square, 3 minus 4i plus 6i minus 8i square. 9 minus 16 into minus 1, the value of I square. Now, normal simplification is here. That is a plus 4i minus 4i 6i get cancelled. And 3 plus 3 is a 6. And again minus 16i square. I square means what? Minus 1. And that's why you will get 6 plus 16 upon 25. And that is equals to 22 upon 25. Which is a real number. Now next question. That is I raised to 29 plus I raised to 39 plus I raised to 49 upon I raised to 30 plus I raised to 40 plus I raised to 50. This type of questions are so we have finished in the exercise. Take I raised to 29 common, then you will get 1 plus I raised to 10 plus I raised to 20, and in next bracket I raised to 30 take common from the denominator, then you will get 1 plus I raised to 10 plus I raised to 20. These two terms will get cancelled, then you will get 1 upon I and multiply numerator denominator by I. That is, you will get I upon I square, which is minus I. Next is I raised to 65 plus 1 upon I raised to 145. Now we'll simplify here. That I raised to 65 can be written as I into I raised to 64 plus 1 upon I raised to 144 into I. I raised to 64 can be written as I square and bracket raised to 32 into I plus 1 upon I raised to, that I square raised to 72. Now this is very simple. Now we have done this. Therefore the answer is I plus again 1 upon I, and now simplify this 1 upon I, that is nothing but the minus I, and I minus I, that is equals to 0. Therefore the answer is 0. Now next is I raised to 238 plus I raised to 236 and plus I raised to 234. I raised to 232 plus I raised to 230. Again this type of, that is a 228, I raised to 226, 224 and 222. I raised to 220, and we can take the common from the numerator and the denominator, which is the lowest term from the numerator and the denominator. The lowest term in the numerator is I raised to 230 and denominator is I raised to 220. Take the common in bracket, you will get the remaining I raised to 8, I raised to 6, I square, I raised to 4, I square and 1. Again that two terms get cancelled, you will get I raised to 10 into 1. I raised to 10 can be I square bracket raised to 5. Minus 1 and bracket raised to 5, that is equals to minus 1. Now next is simplify. Now question number 17. Simplify 1 upon 1 minus 2i plus 3 upon 1 plus I into 3 plus 4i upon 2 minus 4i. Now here 1 upon 1 minus 2i plus 3 upon 1 plus I into, in next bracket, 3 plus 4i upon 2 minus 4i. Now here we will make the cross multiplication. That is 1 plus I plus 3 in bracket 1 minus 2i. And the multiplication of these two terms, 1 minus 2i into 1 plus I. Normal multiplication is there. That is 1 plus I plus 3 minus 6i. 1 plus I minus 2i square. 3 plus 4i, 2 minus 4i. And overall you will get 4 minus 5i. That is 1 minus I minus 2 in bracket minus 1 into 3 plus 4i upon 2 minus 4i. And now simplify this. That is a 4 minus 5i upon 1 plus 2 minus I into 3 plus 4i upon 2 minus 4i. And therefore the multiplication of these two terms, that is a 3 plus 4i upon 2 minus 4i, that is equals to 12. That is a 4 in bracket 3 plus 4i minus 5i in bracket 3 plus 4i upon 3 in bracket 2 minus 4i minus I in bracket 2 minus, that is 6 minus 12i minus 2i plus 4i square. Now this is a simple simplification. That is a 12 plus I minus 20 in bracket minus 1. Therefore you will get, that is a 12 plus I plus 20, 6 minus 4 minus 49, and that is 32 plus I upon 2 minus 49. Therefore 32 plus I, now multiplied with by its conjugate, that is a 2 minus 49, is multiplied with 2 plus 49. Therefore 64 plus 448i plus 2i plus 49 square upon 4 minus 196i square. Therefore 64 plus 440i plus 14 in bracket minus 1, 4 minus 196 into minus 1, and that's why you will get 64 plus 450i minus 14 upon 4 plus 196. Simple calculations are there. You can slow down the speed of this video and write it properly also. Normal steps are there. I had included each and every very simple steps are here. Therefore 1 by 4 plus 9 by 4i. Now next is question number 18. If alpha and beta are the complex cube roots of unity, then prove that 1 minus alpha, 1 minus beta, 1 minus alpha square into 1 minus beta square, and that's equals to 9. Therefore alpha and beta are the complex cube root of unity, alpha square is equals to beta and beta square is equals to alpha. Also, alpha cube is equals to 1. Therefore, 1 plus alpha square is equals to 0. And that's why alpha raised to 4 can be written as alpha cube into alpha, that is alpha. 1 plus alpha square is equals to minus alpha, and 1 plus alpha is equals to minus alpha square. By using that above relation, it's very simple. Therefore, 1 minus alpha in first bracket, second bracket 1 minus beta, 1 minus alpha square into 1 minus alpha this is the values. Now we will substitute. Now see this, I am writing again 1 minus alpha into 1 minus beta into 1 minus alpha square into 1 minus beta square. Substitute the value 1 minus alpha, 1 minus beta means alpha square, and again it is alpha. That all the terms are in the form of the alpha. Now see this 1 minus alpha into 1 minus alpha, that is 1 minus alpha bracket square and 1 minus alpha square 2 times, there again it is a bracket square. Now expand these two, therefore you will get 1 minus 2 alpha plus alpha square, 1 minus 2 alpha square plus alpha raised to 4. Therefore in first bracket 1 plus alpha square minus 2 alpha, and in second bracket 1 plus alpha raised to 4 minus 2 alpha square. Therefore you will get 1 plus alpha square minus 2 alpha. 1 plus alpha raised to 4 means alpha. Therefore 1 plus alpha square is minus alpha minus 2 alpha. 1 plus alpha means minus alpha square minus 2 alpha square. And this is a minus 3 alpha square. And minus minus will become plus 9 alpha cube. 9 into 1, that is equals to 9. And hence it is approved. Now next example, question number 19. If omega is the cube root of unity, prove that 1 minus omega plus omega square bracket raised to 6, 1 plus omega minus omega square bracket raised to 6 is equals to 128. Now omega is a complex cube root of unity. Therefore omega cube is equals to 1 and 1 plus omega square, that is equals to 0. 1 plus omega is equals to minus omega square and 1 plus omega square is equals to minus omega. Now again the same type of the problem here. 1 minus omega plus omega square bracket is to 6 and plus 1 plus omega minus omega square bracket is to 6. One plus omega square minus omega bracket is to 6 plus in bracket 1 plus omega minus omega square bracket is to 6. Therefore minus omega is to 6 and minus omega square, that is omega is to 6. Now very simple, minus 2 omega bracket is to 6 and minus 2 omega square and bracket is to 6. Now here 64 omega raised to 6 plus 64 omega raised to 6, that is 128 can be written as, but okay, no problem. Therefore omega cube means 1 and again omega cube means 1. Therefore 64 plus 64, that is equals to 128 and hence it is approved. Now next Question number 20. If omega is the cube root of unity, then find the value of one plus I root 3 upon 2 bracket raised to 18 and minus 1 minus I root 3 upon 2 bracket raised to 18. Now see this here, we can expand by considering the bracket raised to 3, that is a minus 1 plus I root 3 upon 2 bracket cube, that is equals to minus 1 cube plus 3 minus 1 square plus I root 3 plus 3 into minus 1 into I root 3 bracket square plus I root 3 bracket cube upon 8. Now minus 1, 3 into 1 I root 3 minus 3 I square into 3, that is I cube into root 3 cube means what? 3 root 3 upon 8, that is a minus 1 plus 3 root 3 I minus 9 I square minus 3 root 3 I cube is minus, therefore we can cancel it, that is a minus 1 minus, and their simplification we will get, that is equals to 1. Now for the next term, this is the bracket cube. Again we will find out the value, it's that is minus 1 plus I root 3 upon 2 bracket raised to 18 is equals to minus 1 plus I root 3 upon 2 cube and raised to 6 is 1 raised to 6 means again 1. It's 1, number 1. Also for the next, minus 1 minus I root 3 upon 2 bracket raised to 3. Therefore you will get minus I take the minus sign as common, bracket cube, and overall minus 1 cube, 1 plus I root 3 upon 2 bracket cube. I had taken the minus sign common so that the complication will not be there. Minus 1 cube means what? Minus 1. Now see this expansion, 1 plus I root 3 upon 8, and now expand it. That is a minus 1 by 8, 1 plus and plus, that is a 1 square into I root 3 plus 3 into 1 I root 3 bracket square and I root 3 bracket cube. Now minus 1 by 8. Now see these terms, that is a 3I root 3, and next is I square means minus 1 and square of that is root of 3 is a 3. Now I just make one mistake is there, I square means what? It is a minus 1. That minus should not be present there for the third term. Last term is okay. Third term there must be the plus sign. Now I am changing it now. There is a correction. And that is will be minus 9. Now it's corrected. Therefore, it's a minus 1 by 8 into minus 8, that is equals to 1. And again, its power is 18 power. Therefore, minus 1 minus I root 3 upon 2 bracket raised to 18, minus 1 minus I root 3 upon 2 bracket cube raised to 6, that is again that is equals to 1, and therefore from 1 and 2 the answer is 2. Therefore from 1 and 2, that is minus 1 plus I root 3 upon 2 bracket raised to 18 plus minus 1 plus minus I root 3 upon 2, that is equals to 1 plus 1, that is equals to 2. And in this way we have totally completed the first chapter, that is a complex number with miscellaneous, all the exercise. Okay, now we'll see in the next video. Till then, goodbye. In this way, we have completed the miscellaneous exercise and the complex number whole chapter. Now, if you have any doubt, then write in the comment box, and I will be on the live stream to the next Sunday. If you want to ask some your doubt, you can ask. I will declare my time when I will be in the live stream. Again, if you are new for this channel and if you like this my work, then subscribe it and share it with your needy friends. And if you like this my video, then like it. Now we'll see in the next video. Till then, goodbye.